Hello viewers, you are welcome to my channel once again. Today we are going to discuss, we are still in compound statement. This is the continuation of the compound statement, still under logic. Now we are going to discuss conditional statement under compound statement form. But before then, we know that we said that we use this to define our statements. We say let P Q be statement. Then conjunctive statements conjunctive or called disjunctive connective, biconditional connective, and conditional connective and biconditional connective. Let them be our connective. Be connectives. And I an interpretation. That means I is our assignment of truth value and assignment of truth valuation. So we can use all these ones to define our statements. We are into conditional statement. Conditional statement. Now we are going to use implies connective, that means conditional connective, to define conditional statement by using it to combine two statements together as a compound statement. See what we mean here? We mean that P is our statement, our two statements, our two simple statements. Now let us use the conditional connective to combine them as a single statement called conditional statement. That means P implies Q. You are using it now. You are using the connective to form a compound statement called conditional statement. Read as P implies Q. You say that this is a syntax of conditional statement. Here, P is called antecedent, while Q is called consequence. P is called antecedent, while Q is called consequence. P is called antecedent is because it's the consecutive of the effect of the Q. Why Q is consequent? Because Q is the effect of the causative P. That's why P is called antecedent, why Q is called consequent. Let's go to their semantics. You can now know, you have now known, whenever you see P implies Q, you have known that it is what? A conditional statement by the syntax P implies Q. Then you go to the semantic. It said that I of PQ is equal to F if I of P is equal to T and I of Q is equal to F. Otherwise, T. That means truth. Otherwise, truth. Otherwise. That means in the semantic of conditional statement P implies Q, we have false if I assign P to T and I assign Q to F. That's when you're going to have false. But otherwise, anyhow you combine it, apart from this combination, it will give us T. You say this is the semantics of conditional statement. So this is the semantics of conditional statement. That means the statement, conditional statement, is related to false if I of P is equal to T and the I of Q is equal to F. That's only when it's going to be false, but otherwise is truth. So let's go back to the statement to show all the possible combinations and the valuations of the conditional statement P implies Q. Example, of truth table for conditional statement. Say, write the heading truth table. We draw the table. Then the first row will contain our statements. We draw the columns for the statements. Then we have, since we have two simple statements that are involved in the conditional statement, that means P and the Q. And our formula for determining the rows in truth table is 2 power n. Then that n denotes the number of simple statements that are involved in the compound statement. That means here you're going to have 2 power 2, and 2 power 2 is equal to 4. You're going to have 4 rows. You have number 1, 2, 3, and 4. You know that our first row it contains our statements, and we have P, we have Q, we then have our compound statement, that is the conditional statement. P implies Q. Now, let us, because we want to get all the possible combinations of P and the Q, our simple statements, how can we combine their truth values? How can you combine them? So we want to get all the possible combination. What we do that, since we have 4 rows, we are going to divide them into 2. That means 4 divided by 2, which is 2. So we are going to make sure that the first 2 rows contain T, that means truth and truth. Then the last 2 rows, that means the third and fourth rows, contain F, that means first and the first. See what we mean here? T, F, F. Then we divide, since the 2 rows contains TT, we divide it by 2, so that we know how to insert our truth value to the values to the rows under column Q. Now, if we 2 divide 2, we give us 1. That means we are going to have, first of all, T, second, first, another one, T, second, first. That means you have T, F, T, F. Let's go to the valuation. Now, we say that we can have the statement to be false if I assigns P to T and assigns Q to F. That's only when we can have false in that statement. Otherwise, it will be truth. That means here in second row, I assigns P to T and assigns Q to F. That means here we're going to have truth valuation of false. So here we have false. So otherwise, then T and T will give us truth. F and T will give us truth. That means F implies T. This means T implies T will be T. Then F implies T will be T. Then F implies F will be also T. So that is the truth valuations of P implies Q. When they are being combined in different ways, we have T, F, T, T. So that is the truth table of biconditional statement. Let us go over to types of conditional statements. Types of conditional statements. We say there are three types of conditional statements. There are three types of conditional statements. Namely, converse statements, inverse statements, and the contrapositive statements. These are the three types of conditional statements. One is converse statement, second is inverse statement, and third is contrapositive statement. Let's discuss them one after the other. Let's start with the converse statement. Converse statement. Very good. If you say that if P implies Q is conditional statement, then Q implies P is a converse statement. That is that. We have seen that we have P implies Q as a conditional statement. If this is a conditional statement, that means Q implies P is our converse statement. What do we mean? Here we can say that Q now has become antecedent, while P is consequent. Formerly, P is in conditional statement, P is the antecedent, while Q is the consequent. But now reverse is the case. That's why we call it converse statement. So we can know it by the syntax that Q, when P implies Q is a conditional statement, then Q implies P is a converse statement. So it has the same semantic with a conditional statement P implies Q. That means is false when I assigns P to F and assigns Q to, so when I assigns P to T and assigns Q to F, that's when we have the valuation of the statement as false, but otherwise it is true. So let's go over to the truth table of converse statement. Example of truth table of converse statement. The example is a truth as heading, truth table. We draw the truth table, the same thing with conditional statement. We draw the first row that contains our statements. Then we draw the columns for the statements. Then rows for our truth value and truth valuation. Row 1, row 2, row 3, and 4. Then we have P, we have Q. Then we have Q, sorry, they use blue ink. We have P implies Q. Very good. Since you have two simple statements, sorry, it's not P implies Q, it's wrong. Is Q implies P. That is the converse statement. The other one is the conditional statement. So, since we have two simple statements in the statement form called converse statement, that means we are going to have 4 rows, because we know that our formula for determining rows in truth table is 2 power n. Then our n here is equal to 2. That means have 2 power 2 equal to 4. That's why we have 4 rows. So we are going to assign TT to first 2 rows and then FF to the last 2 rows. Then we have assign, we're going to write T here, F here, T here, F here. Then we know that we can only have false in this statement when I assign Q to T and assigns P to F. That is when we're going to have false valuation. Here, Q is what? Q is F. Then P, I assign P to T. That means it is truth. It is when I assign Q to T and assigns P to F. That's when we are going to have false valuation, truth valuation. Then here, I assigns Q to T and assigns P to F. That means this one, I assigns Q to T and assigns P to F. That means T implies F will give us false evaluation. That means here will be false. We say otherwise is truth. Now here we have I assigns Q to T, assigns P to T, assigns P to T. That means T implies T will give us T. Will give us T. Here I assigns Q to F and assigns P to T. That means F implies T. Not, you're going to have false when I assigns Q to T and assigns P to F. That's going to have false. But here I assigns Q to F and assigns P to T. That means it is truth. Here we have I assigns Q to F and assigns P to F. That means it is truth otherwise. So that is the statement truth valuation in this compass statement. You have T, T, F, T. When they are being combined with different truth value, like here Q is T, P is T, so it is T. Here Q is F, P is T, that means F implies T is T. Here is the case where it will be false. Q assigns to T, P assigns to F, that means T implies F will give us F. Then here Q assigns to F, P assigns to 1, that means F implies F is T. So that is our truth table for compass statement. Let's go to the inverse statement. Inverse statement. We said that if P implies Q is a conditional statement, then not P implies not Q is an inverse statement. We have seen it that if P implies Q is a conditional statement, then not P implies not Q is an inverse statement. You know that this is negative connective. This is a negative connective. So you need to they use it here. You say like not P. That means if this one is truth, this one is false. If this one is false, this one is truth. That means if P is true, not P is false. Is not P is true, then P is false. That's what it means. Then here we have seen the syntax of inverse statement. So when P implies Q is a conditional statement, then not P implies not Q is an inverse statement. That means if you have not P implies not Q as a conditional statement, then P implies Q will be our inverse statement. So that is the syntax of inverse statement. Let's go to their semantic. They have same semantic with the conditional statement. That means whenever I assigns not P to T, then assigns not Q to F, it becomes the evaluation of the statement becomes false. Otherwise, it is true. Let's use the table to show all the possible combinations of the state, the truth value of the statement and their valuations. You say example. Example of truth table for inverse statement. We have it. The inverse statement like this. We have our first column that contains our statements. Our first row, the first row contains our statements. Then we have columns. The initial columns contain our simple statements. Then followed by proper statement. Then second, we have first row, second row, third row. We have not P, then let's say we have P, we have Q. Then let's draw our row. We have normal truth values. That means here will be T, here F, here F. Then here will be T, here will be F, here will be T, here will be F. Now, we have here not P. Remember that we said that whenever P is true, then not P will be false. Whenever not P is false, P will be true. Whenever not P is true, P will be false. So let us draw column for our not P. Very good. We call this one not P, this one not Q. Under it we have here is P, here is T, P is T here, that means here it will be false. P is T here, that means here not P will be false because it is T. Here P is false, so not P will be T. Here P is false, so here not P will be T. The same thing here. Q is T here, then here not Q will be false. Q is false here, not Q will be T. Q is T here, not Q will be F. Here, Q is F here, then not Q will be T. Then the valuation P, not P implies not Q. That is our valuation. Not P implies not Q. We said that we can only have false truth valuation when I assigns not P to T and then assigns not Q to F. Here not P assigns, I assigns not P to T and then assigns not P to F. That means here will be false. Here will be false. Then I think the other one will be truth, because I assigns not P to F. I assigns not P to F, assign not Q to T. It is true. It is only when I assigns not P to truth and assigns not Q to F that when it will going to be false. Then here I assigns not P to truth and assigns not Q to F. That means it is false. Here it will be false here. Then the rest will be truth, because not P is assigned to F and not Q is assigned to F. That means F implies F will give us T. Here not P is assigned to F and not Q is assigned to T. It means that F implies T is T. Then here T, not P assigns to T and not Q assigns to T. That means T implies T is T. That is the truth table. Let's find where to write it here. Truth table. So that's the truth table for inverse statement. You have T, T, F, T as our truth evaluation when they are being combined in different ways. So this is the example of inverse statement truth table. Let's go to the last one called contrapositive statement. Contrapositive statement. Then we said that if P implies Q is a conditional statement, then not Q implies not P is a contrapositive statement. That is our conditional statement. When we have not P as our antecedent, then not P as our consequence, saying is a contrapositive statement in relation to this conditional statement. There this one will come here and becomes not, this one will go here and becomes not P. If it comes here, it becomes not Q. If P goes there, it becomes not P. That's why it's called contrapositive statement. So this is the syntax of the contrapositive statement. And whenever P implies Q, then not Q implies not P. The same thing, you have the same semantic with the conditional statement. So let us draw the table. Example of truth table for contrapositive statement. It's a truth table we draw the truth table. These are truth table. The first row contains our statements. Then we have our column, our first initial column for our simple statements. Yes. We have first row, second row, third and fourth row. That is that. We then have P implies P and Q as our simple statement. Then you have our negation of not P and not Q and not P. We draw another column to contain our not P and another column to contain our not Q. We write them. We say not P, not Q. Then our statements, the contrapositive statement is not Q implies not P. Here we have our normal T, F, T, F, T, F. Here is the negation of the P. If P is T, then not P will be F. If P is F, not P will be T. Here P is T, then not P will be F. Here P is T, not P will be F. Here P is F, not P will be T. Here P is F, then not P will be T. Very good. Now we go back to not Q. Here Q is T, not Q will be F. Q is F, not Q will be T. Q is T, not T will be F. Q is F, not F will be T. Then let us evaluate our contrapositive statement. Not Q implies not P. Here we can only have false when I assigns not Q to T and assigns not P to F. Here I assigns not Q to T and assigns not P to F. So here we're going to have false statement, otherwise truth. So here is T implies F, so it is false. Here we have F implies F, will give us T. Here we have F implies T, it will give us T. Here have T implies T, give us T. So this is the truth table for contrapositive statement. So this is all about types of conditional statement. Thank you, viewers.